In this class, we discuss the software to run Valeria. So you are going to receive this folder, Panoramic Control Panel. The last version is 1.11. You double click over here. Inside there is the executable. So you just double click over here and the software is launched. So this is the control panel for Valeria. First of all, we check by these arrows if actually the camera, the panoramic head is connected. So we click this one and we should see the camera turning counterclockwise. We check this one, the camera turns clockwise. Then this one should be up, should go up, and this one should go down. Okay, you are going to receive the camera functioning this way. If you want to, for some reason, if you want to change how the behavior of these arrows, you can go here in setting. So basically from setting you can change what the arrows do. I mean, this is something, this is a motor port, pump port, tin port. This is nothing you have to change unless you want to do some advanced experiment, so with the camera to use for anything you desire. Otherwise you will receive, these are the default values and they work as just as fine. Okay, at this point we go back here and we prepare the scanning of our experiment. Remember, we did the Pigment Checker, so the Pigment Checker is over here on the table. The idea is to set up this experiment, we need to run the software for the camera. So there it is, Xenix. Okay, there it is, the software, connect the camera. Okay, the camera is over here. The image is dark because there is no infrared right now. So let's turn on some IR lamp. Okay, so now we have the helio halogen lamp is on. Let's move the camera. Okay, there it is. So this is our Pigment Checker. Let's click here. It's very useful. This is a scale. So this is an histogram. So we can make the image more contrasted. So we can see much more details. And also actually let's make, see in the calibration, let's use longer exposure. Okay, so the image will now look overexposed. And we go down here and we can close the aperture of the lens. So we start to see something. Okay, so let's have more contrast so the image is more pleasant. Okay, something like this. Okay, there it is. We have a Pigment Checker over here. So let's put the software over here. And then this is the camera, the panoramic control. Before starting using the panoramic head, we need to set up the FOV, field of view. So it's over here, the field of view. In this case we have here 43 because I already tested with my camera. So if you are using another camera with another lens, you need every time to find out what is this FOV for your specific system in terms of camera and lens. So to do this we can calculate automatically. So this is the procedure. you need to define a line, for example this one over here on the Pigment Checker, the upper border. So this will be the reference line. So what I do is I put this reference line on the top of the image of the camera. So I move this one, the camera, okay, it's almost there, it doesn't have to be precise. And then I click Set Y Endpoint 1. Then I need to move this line to the bottom. Okay, so I go up and the line goes down. Okay, there it is. And I click Set Y Endpoint 2. So you see now the field of view is 55. Okay, so I'll change a little bit. Okay, pretty good. Now, once we define the field of view, we can work into our to make our panoramic view, to define the panoramic view. So the goal of this work today is to scan the Pigment Checker. So I start from the top left of this image. So there it is, and here we have two buttons. Set top left corner. So I click here, and there it is. Then I go down, and then I move the other direction over here, and there it is. Okay, so this one will be the bottom right corner. So you see, basically right now, what happens is that the software figured out how many images needs to make this acquisition. So in this case, we have two columns made of 4 rows from this distance at this resolution. Okay, before starting the acquisition, we need to go into setting. Because the idea is to use the camera in an automatic way. So it means that Valeria moves the camera and in the meantime shoots the software. So in every position the image is saved into the computer. Okay, so we need to be sure that this one is checked. Photo shooting software. And here we need to input the name of the software. By the way, the name of the software means it's the name of the application, the executable of the software that the computer see. So when you, for example, do Control Alt Delete, on the computer, you see the task manager, you're gonna see XenF64. This is the software that runs the computer, the software that runs the InGaAs camera. And then basically we can send a command to this software for shooting. So you see here already is set up to send F11. We can delete this one. Why is F11? Because basically for this software, for the InGaAs camera software, F11 is the command to take a picture. So we go here in image, you see save snapshot is F11. So this is the idea. Let's make a test first, because the software wants to know for the first image where to save these images and how to name it. Let's call it, so we go on the desktop, for example, we make a new folder, we call it Pigment Checker. Okay, so this will be our image over here, and file name we want to make PC for Pigment Checker. Okay, save. Okay, let's go on the desktop. Let's see where this folder is. Pigment Checker. Okay, so far there is no image. Let's put it on the side. So this is the software. So if I go here, image, say save snapshot, the image is over here. Okay. Okay, we can delete this one, and now we are ready to operate the machine. So F11 is over here in the software, in the Valeria software. We can leave everything else as it is. In particular, over here you see we have a camera ratio. These values depends on the kind of camera you are using. And also here we have, so basically when you have a photographic camera, the ratio is a 3:2, like standard a DSLR camera. For this kind of cameras, you see the format is quite, it's more squared. It's like more a square than a rectangle, and the format is 5:4. Okay. Then here we have how much overlapping we want to have in our images. So we can input like 0 overlapping, so the image will be really far away, or we can have 10–30% overlapping on the x-axis and the y-axis. So this is something that we can input. 30 is pretty fine. And then we have shooting delay. So generally 2 seconds, it's fine. The idea is that once the camera is moved in the new position, waiting 2 seconds to make the shoot in order to stabilize the camera. We don't want to have vibration in the acquisition. Okay, so everything is set now. We can click here test keystroke to see if actually we are able through Valeria software to shoot the InGaAs camera. And there it is. See, the image is saved over here. Okay, then we go in control panel, and now basically we are ready to automatically do this acquisition, which now is pretty simple because it's just 4 images. Okay, start photo sequence. So the camera go back to the first position, and the first position is acquired. Indigo, the last one now is a cobalt titanite green, and it's over there. The overlapping in this case is not that much. Okay, so we could have more. It's up to us to figure out if, in order to have a better image than to stitch. That's the thing. Okay, there it is. So the advantage of this method is that stitching could be a little bit of a long process, because we use the Panoramic software, but still we need to do adjustment the software because the images are so small, so it's not easy for the software to stitch them together. The advantage of this method is that it's very fast to acquire the image. So you see, we go here, and basically from here we can have and see the image. So if there is anything we notice, we can tell immediately. Okay, thank you. So this is all for the acquisition of